Hi. The satellite communications industry is going through a transformation with an evolution towards 5G non-terrestrial networks. This transformation brings the promise of delivering standard ubiquitous connectivity across both terrestrial and non-terrestrial networks. It sets the stage for a dynamic multi-vendor open ecosystem and introduces new revenue streams for satellite operators worldwide. My name is Yaron Nachman, and I am a 5G product line manager at Gilat. In this presentation, I will discuss key strategies for seamless and secure transition to 5G NTN for satellite operators. Let's start. Satellite networks are starting their long journey from vendor-specific non-interoperable solutions towards standard interoperable solutions driven by 3GPP 5G NTN specifications. The target is to have a large ecosystem of interoperable products from different vendors that will allow satellite network operators to reduce their CapEx and OpEx. Already today, 5G brings many functionalities and values to the table from the terrestrial world. Mobility management, session management, user management, policy control, charging, analytics, security, network slicing, and more. Add to that BSS and OSS systems that were developed for 5G terrestrial networks and can be reused for NTN. The value-added services and applications that can be added to the 5G open architecture, and the cloud and edge computing that allows scaling, high availability, and low latency capabilities. All of those are ready to be used for 5G NTN solution. 5G New Radio is being enhanced by 3GPP for NTN to overcome challenges of link budget, delay, Doppler effect, timing synchronization, positioning, and satellite mobility, but at the same time will benefit from the availability of the disaggregated Open RAN specifications and products ecosystem. So what are the benefits of 5G NTN? First, the ubiquitous connectivity, extending text, voice, video, and broadband 5G services to remote and unserved areas globally. The 5G promise of anytime, anywhere cannot be fulfilled without 5G NTN. Service monetization. Satellite network operators can leverage 5G terrestrial monetization systems, allowing onboarding of new customers, providing new services, and getting new revenue streams more quickly. Operational efficiency. Satellite network operators can adopt 5G terrestrial operation systems, reducing OpEx and CapEx while enhancing customer experience. Standard interoperability. Ecosystem of standard-based hardware and software products, allowing multi-vendor interoperability and cost reduction. Diverse use cases. 5G NTN supports use cases ranging from direct-to-device and IoT to mobility, cellular backhaul, and private networks. I will talk about it in the next slide. And future-proof. 5G NTN standards are forward-looking, allowing for easy integration of future technologies and standards, like non-3GPP access, 6G, and more. 5G NTN opens up opportunities for diverse use cases. Direct-to-device. This is one of the hottest use cases nowadays, where mobile network operators and satellite network operators are partnering to provide communication services directly to handset devices in areas that don't have cellular coverage. Some do it with unmodified smartphones using MNO spectrum, while others will rely on 3GPP Release 17 modified smartphones that include chipsets with 3GPP NR NTN support. Services start from SOS and text messaging with the intention to grow to voice and data services in the next years. IoT NTN. Standard satellite IoT connectivity for sectors such as agriculture, asset tracking, maritime, oil and gas exploration, utilities, construction, and government operations. Cellular backhaul. Satellite networks already today provide cellular backhaul services for 4G and 5G mobile networks that don't have a fiber or cable or microwave connectivity. Gilat is a market leader in 4G cellular backhaul with its SkyEdge solution and will continue to lead in 5G. Private networks. Private 5G networks with sites in remote locations, such as oil rigs, mines, or maritime vessels, need satellite connectivity to interconnect their distributed locations and connect to the cloud. Automotive. The automotive industry needs features that have real and tangible implications for the consumers, such as the ability to initiate breakdown or emergency calls regardless of the location, the ability to control and service cars remotely, as well as over-the-air updates, enabling new functions to boost vehicles' security, traffic safety, and overall efficiency. The 5G Automotive Association, the 5GAA, leads the efforts in front of the 3GPP 5G NTN specification. Aero. 5G NTN is also a hot topic in the aviation industry and is in the focus of the Seamless Air Alliance, the SAA, specification body. There are multiple use cases that are relevant for 5G NTN, like in-flight connectivity, live television for passengers, airline and airport administration and operation, and air traffic management. Maritime. 5G NTN will provide standard-based solution for the maritime industry. Global coverage over the oceans, continuous connectivity between ships, ports, and onshore operations, emergency response and safety, operational efficiency, and crew welfare services. Residential. 5G NTN is important also for the residential market, as it will provide standard 5G connectivity to homes via satellites. Currently, satellite service providers like Starlink provide such services via proprietary closed solutions. Standard 5G NTN will provide an opportunity to open up the market and reduce costs for residential customers. So looking at the future evolution of 5G NTN standard and market, we can see that cellular backhaul of 4G and 5G networks is supported today in overlay mode with high gigabit per second bandwidths of current optimized DVB-S2E technology. Gilat is a market leader in this cellular backhaul over satellite. Then in the coming 2 years, 5G NTN narrowband services will start to be supported. First on unmodified smartphones and then on new release 17 smartphones and IoT devices. Starting 2026, 5G NTN broadband services will start to appear on new VSATs and modems that are based on release 18 NTN capabilities. And last step, starting 2028, 5G NTN enhanced broadband services will come with VSATs and modems based on release 19 NTN capabilities and new regenerative satellite constellations. All in all, 5G services will evolve during the next 5+ years with higher bandwidth, lower latency, and higher capacity. The actual evolution timeline will greatly depend on the 3GPP NTN specification maturity and the availability of chipsets and other space and ground segment technologies and products. This is the reason why satellite network operators need to implement the right strategies for a seamless and careful transition to 5G NTN. Here at Gilat, we've dug deep into the crucial strategies that guarantee seamless 5G NTN integration without compromising existing investments and business continuity. Based on our findings, we designed our next-generation SkyEdge 4 platform to enable the smoothest transition to 5G NTN. Strategic evolution is most important, preserving existing investments in technologies such as DVB-S2X while ensuring uninterrupted business continuity. Recognizing that the shift to 5G NTN is not a one-size-fits-all process, a phased approach emerges as the preferred strategy, allowing operators to systematically upgrade their infrastructure. This method mitigates risks and guarantees a smooth transition without disrupting ongoing operations. Preserving investments in current technologies, particularly DVB-S2X, is key to a cost-effective transition. Through strategic integration of 5G NTN elements such as 5G core, G-Node Bs, and terminals alongside existing systems, operators can capitalize on the advantages of both technologies while minimizing disruptions to ongoing operations. The phased approach offered by Gilat, in addition to preserving business continuity, allows thorough testing and validation at each stage, ensuring the success of the transition before advancing to the next phase. Securing the long life of SNO infrastructure demands to select a platform that explicitly designed to accommodate upcoming standards, ensuring both adaptability and seamless integration across many waveforms. The 5G NTN journey, marked by continual advancements in standards and technologies, needs a platform that is capable of easily adapting those changes without having extensive hardware upgrades. In this always evolving scenario, flexibility is very important. SkyEdge 4 will support various waveforms, guaranteeing compatibility with an array of satellite communication technologies. This adaptability is necessary as the industry explores diverse frequency bands, modulation schemes, and satellite constellations to fulfill the growing demand for ubiquitous connectivity. The basis for a seamless transition to 5G NTN lies in the adoption of a virtualized all-software platform designed to operate efficiently on standard off-the-shelf hardware. This shift towards virtualization empowers network operators with three advantages: flexibility, scalability, and cost-effectiveness. By decoupling software from dedicated hardware, operators can leverage the capabilities of commodity hardware, resulting in a substantial reduction in both CapEx and OpEx. Beyond the cost benefits, SkyEdge 4's virtualized platform will streamline resource allocation, ensuring optimal performance based on demand. This not only increases operational efficiency, but also sets a dynamic software-defined network architecture. This architectural shift enables seamless adaptation to evolving requirements and emerging technologies. Digital modem CNFs with digital interface like DIFI and data processing CNFs will run on a compute, storage, and networking COTS hardware as part of the public or private cloud infrastructure. The SkyEdge 4 Elastic Total NMS is seamlessly integrated with cloud service orchestrators, enhancing the platform compatibility with cloud environments. The standard interfaces enable smooth communication between SkyEdge 4 and various cloud management tools, such as Kubernetes. Satellite network operators are relying today on DVB-S2X technologies and solutions that were optimized for years to cope with satellite communication challenges and moves best performance satellite communication solutions as of today. 5G NTN is still under specification in 3GPP, and it will take multiple years to prove that its performance is on par and even better than current DVB solutions. However, 5G is regarded as network of networks, allowing 3GPP and non-3GPP access networks to integrate with the 5G core, to become converged network and allow common network operations and service monetization. 3GPP and other standard specification bodies like the BBF and Cable Labs have defined solutions for fixed mobile convergence, which the satellite industry can adopt and adapt to integrate existing DVB-S2X satellite access networks with 5G core using an access gateway functions. While 5G Core provides standard management and control solution for users and services, the Total NMS unified management is key for seamless integration, as it overarches current satellite solution processes and maintaining the integration with 5G Core. So what are the benefits of a hybrid NTN? First, we are talking about the standard 5G Core. SNOs can use 5G Core access agnostic system to provide standard management and control for users and services. Monetization and operation. SNOs can use standard BSS OSS management orchestration software with standard APIs to monetize services and automate their operations. Evolution at your pace. SNOs can reduce risk, validate and use 5G Core and BSS OSS and orchestration solutions prior to market availability of 5G NTN satellites, hubs, and terminals. TN-NTN mobility. Use standard mobility and roaming capabilities between 5G TN and non-3GPP NTN for mobility use cases. Preserve investments. By integrating DVB-based networks to 5G Core, SNOs enjoy the benefits of 5G Core without throwing away their past investments. And last but not least, best of both worlds. Hybrid NTN uses proven best performance DVB-based satellite access network technology together with standard service-based 5G Core technology. The target will be an end-to-end 5G NTN solution that is compliant with the 3GPP Release 18 and Release 19. The solution will support new NR-NTN waveform that is optimized for leak budget, delay, Doppler effects, satellite mobility, time and synchronization, positioning, as well as TN-NTN spectrum interference and TN and NTN mobility challenges of non-terrestrial networks. New spectrum bands are defined in the KN and KU bands. New chipsets and products will be available for VSATs, satellites, and gateways, which will support 3GPP NR-NTN. ORAN-based G-Node B software will be adapted for NTN, including the challenges introduced in transparent and regenerative NTN architectures. Based on virtual platform architecture, the G-Node B NTN software is just a matter of software upgrade. Space segment technologies like optical ISLs and edge computing will be used in satellite OBPs to provide better solution flexibility and functionality. When it comes to the network management system for both current DVB-S2X and future 5G NTN waveforms and platforms, envision the NMS as the central nerve system of the network. It offers real-time monitoring, configuration, and optimization capabilities. Investing in a robust NMS that can handle the details of both current DVB-S2X and 5G NTN platform is crucial. SkyEdge 4 Total NMS seamlessly integrates with both legacy and future platforms, simplifying operations and reducing the learning curve for both administrators. This unified approach enhances overall efficiency, enable operators to manage and monitor the entire hybrid network ecosystem from a single interface, as well as having standard open APIs to northbound systems, such as BSS, OSS, service orchestration, and satellite resource manager. To summarize, the transition to 5G non-terrestrial networks signifies a leap forward in the satellite communication industry, using the power of the virtualized all-software platform, integrating future standards, implementing a phased evolution strategy, and investing in a versatile network management system are key elements that ensure a seamless and future-ready transition. With virtualized platform and hybrid NTN solution, SNOs can evolve to 5G NTN at their own pace, preserve network investments, and enjoy the benefits of 5G ecosystem much earlier. Thank you.